Howdy, howdy, howdy. We're talking subtraction. We're talking decimals. We're talking subtracting decimals. So let's get to it. All right, so subtracting decimals, it's extremely similar to adding decimals. And the good thing about subtracting and adding decimals is that it's not that much different than this straight up addition, straight up subtraction that you've been doing since grade 1. So let's get to it. A number 21, yeah, why not? 21 take away 13. Cool. This is your little refresher, by the way. So 21 take away 13. First, I start in the lowest place value I have, so that's the ones right now. 1 cannot take away 3. 3 is bigger than 1. Doesn't work. Okay, so in order for me to make the subtraction, yep, I'm going to have to borrow. I'll borrow from the next place value. So 2 tens turns into 1 10. And my 1 turns into 11. 11 take away 3, yep, that is 8. And 1 take away 1 is nothing. Cool. So there's my answer. 21 take away 13 is equal to 8. Now, what does that look like when it's actually a decimal number? So, you know what? Instead of 21, I'm going to go 2 and 1/10. I could also say 21 tenths, but 2 and 1/10 always works. And yep, you guessed it. I'll subtract 1 and 3/10. So the same numbers, just there's a decimal now, right? And I shouldn't say the same numbers because they're not really, and they're not representing the same value. 21 is a lot bigger than 2 and 1/10, and so is 13, way bigger than 1 and 3/10, but the same digits, okay? So same pattern. Anyhow, let's subtract. Before I do that though, notice, just like we learned when adding decimals, we have to stack the decimals on top of each other. When adding or subtracting decimals, the decimal itself is your key. So you need to pay attention to what your decimals are doing. Otherwise, you're going to make a mistake and you won't get the correct answer. So anyhow, I've lined up my decimals. And in so doing, I have also lined up my place values. My ones are stacked on top of each other. My tenths are stacked up on top of each other. And that's going to allow me to actually carry out this standard algorithm. And remember, the standard algorithm is just when you have a number on top of another number. The top number is having the bottom number subtracted off of it. So standard algorithm. So anyway, first step is done. I've lined up my decimals. Second step, yep, drop the decimal down, still in a perfect straight line so that our place values are lined up. And last step, yeah, let's just subtract. 1 cannot take away 3. I'm going to have to borrow. 2 ones turns into 1 1. 1 tenth turns into 11 tenths. 11 tenths take away 3 tenths is 8 tenths. Yep, and 1 take away 1 is nothing. And I could write my answer like this. Just, 0.8. But you know what, just for fun, I'm going to put a 0 in there just to represent 0 ones as well. Now, take a look at our answer as well from both of these. 21 take away 13 is 8. Or I could also say 21 ones take away 13 ones is 8 ones. And I can say the same thing down here, except it's tenths. 21 tenths take away 13 tenths is 8 tenths. So the pattern stays the same. The difference is that we have a decimal in the middle here. And it's literally 10 times smaller because it's base 10. Every time you move up or move down a decimal, you're either multiplying or dividing by 10. Anyhow, that is how you do it the quick way with standard algorithm. This is really quick. You line up your decimals, you find your answer. And that's awesome. If you know how to do this, that is really good. You're going to do well on the test. And that's fine. But what's even cooler than just getting a good mark on a test that doesn't really matter is actually understanding what's happening. So let's visually represent this. So I'm going to use a flat. My goodness, that's huge. Let's have a zoom. Okay, there we go. I'm going to use a flat to represent the ones. Okay, so 2 and 1/10. Let's represent that right now. So there's 2 and 1/10. Very good. Okay, now I'll go 1 and 3/10, and I'm going to make this. Let's make it orange or red. Why not? Sure. Cool. Okay, so that's 1 and 1/10. We'll make him red as well. And then we'll just copy him. Boom, boom. Cool. So 1 and 3/10, 2 and 1/10. Let's start subtracting. And when you're subtracting with these base 10 blocks, essentially what you need to do is just cancel numbers out. So I can do that right now. So 1/10 cancels off another tenth. That's awesome. So these are gone. They're canceled. Easy. But uh-oh, How do I cancel off this tenth or this rod when there's none up here? Well, I have to remember that any one of these flats is actually equal to 10 rods. Or I can also say 1 is equal to 10 tenths. So let's go ahead and do that. Grab a rod, and I'll copy him. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've broken this flat into 10 rods. And this is exactly the same as what I was doing when I regrouped, right? Or when I borrowed, rather. So I borrowed from 2 1s to give me 11 tenths. That's exactly what I just did. I broke up my flat, giving me 10 tenths, plus my 1. I've got 11 tenths now. This is visually what's happening when you're borrowing, when you're subtracting. So anyhow, I'll shut up. Let's keep going. Leave my little pen here. Okay. So anyway, let's cancel off this rod, and he'll cancel with this guy. This guy's gone. Canceled. Okay. Cancel this guy. This guy is also canceled. Awesome. Okay, and I see we have just 1 left over. Let's cancel him off. Easy peasy. All right, and now that I've got nothing else left to cancel, all I got to do is count what's left over. So I say I have 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 tenths left over, and that is exactly what I had when I used the standard algorithm. But except the difference is I visually showed it this time. So it's awesome to learn the tricks and get good marks on tests. That's great. But what's more awesome is actually understanding what's happening. And again, when we borrow from bigger place values, essentially what we're doing is just breaking down a bigger block into 10 of the next smaller block. That's borrowing, okay? And it's no different with whole numbers than it is with decimal numbers. Because we have to remember that every place value, right? If I have hundreds, tens, and ones, every place value is just 10 times bigger than the last one. Times 10. Times 10. Same thing there. Okay? And if I want to go the other direction, it's dividing by 10. And that's exactly what I just did. This flat was divided into 10 rods. Or this 1 was divided into 10 tenths. Cool. So I hope that helped. Happy dividing, okay? Don't only just use a standard algorithm and get 100%, but know and understand what the heck it is you're actually doing. Have fun.